2, 3.
Assalamualaikum and hello everyone. So today we are going to present experiment 7, which is estimation of heat capacity and entropy generation. Next. So this is the name of students in our group, which is YUSUP, OMAR, SAEFULLAH, AMIN, and HAFIZ IZZUDDIN in JIMAT. Next. So this is a table of contents. Uh, this one is the introduction, objective, theory, principles, experiment setup, methodology, results and discussion, safety procedures, conclusion, lastly references.
Okay, this is an introduction. In this experiment, the heat capacity of the substance can be defined as the amount of heat required to change its temperature by 1 degree Celsius. And the second of this introduction is second law of thermodynamic that we use in this experiment. So the total entropy does not change during the reversible process, and the entropy generation is measure of the magnitudes of irreversibility present during the process.
So for the objective, which is to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped in a container containing water. So there are list of scope that we use while conducting the experiment, which is first is utilize three different type of metal, which is copper, aluminium, and iron. Second is the temperature range from room temperature until 80 degrees Celsius. Then mass of water used is limited to 0.1 kilogram for both liquid. Plus time recorded temperature for water at second liquid is every 10-second interval.
Okay, so moving to a theory and working principle part. So the specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kg of substance by 1 degree Celsius. So the below is the formula to calculate the specific heat capacity. So M stands for mass, and then in kg, the unit, and then C is the specific heat capacity, and then the unit is joule per kg multiplied by degree Celsius, and then the change in the thermal energy is in unit joule, and change in temperature in degree Celsius. Next. So a substance with low specific heat capacity heats up and cools down rapidly. A substance with high specific heat capacity heats up and cools down slowly. So one of the good example is the water. So water have high specific energy, means that water have high specific heat capacity. So the reasons why is because the strong bond in the water molecules. So water molecules have hydrogen bond, and water molecules is also a polar covalent molecule. So it takes a lot of energy to break the bond, and also takes a lot of energy to form the bond. So that's why it has a high specific energy. So humans are composed of about 70% of water, and this is also a reason why our own body temperature do not fluctuate that much. Next. So it takes due to water takes a lot of energy to gain or lose temperature, it makes water habitable because it does not constantly fluctuate in temperature. So this also allows marine life to live in the ocean. So in our experiment, we are taking copper, aluminum, and iron. So different substances will have different ability to absorb heat. So they will have different value of specific heat capacity. So in our experiment, we apply the first law of thermodynamics. So first law of thermodynamics states that energy cannot be created nor destroyed, but it can be transformed from one form to another. So in the picture in the left hand side, we will heat the water. So we provide energy to the water. So when we put the in the second diagram, we put the copper inside the beaker. So when we heat up, when we place the copper inside the beaker, so there is heat transfer between the water and the copper. And then when the copper reach 80 degrees Celsius, we move it into a third diagram, which is a room temperature water. So we assume that heat energy from copper metal is transferred to room temperature water. So energy is not destroyed, instead they are transferring from one another. Next. So based on the second law of thermodynamics states that processes occur in a certain direction, not in just any direction. So we are known that always the heat energy will transfer from a hot body to a cold body. Next. So in this case, as explained just now, so when there is heat energy transfer between the copper and the water, it is known that the heat energy will flow from the hot copper towards the cold copper, and from hot copper towards the room temperature water. So this one is the formula to calculate the specific heat capacity of experimental value of copper metals, aluminum metals, and iron metals. So heat loss by the object is equals to heat gain by water. So heat loss by object, we know is calculated by using mass multiplied by specific heat capacity and multiplied by the change in temperature. So T2 is the final temperature of solid metal when reached equilibrium, and T1 is the initial temperature of solid metal. And M equals to mass of solid metal in kg. And then heat gain by water, also the same, mass multiplied by specific heat capacity multiplied by the change on the temperature. So T2 is the final temperature of water when reached equilibrium, and T1 is the initial temperature of water. So Cp value is the specific heat capacity, and M is the mass of water. So at equilibrium, the T2 means that the final temperature of solid will equals to the final temperature of water. So the heat capacity of water is known and mass is known, and then change of temperature in water and then change in the temperature in matter is known, and also the mass of matter is known, so we can calculate the Cp value for the matter. Next. So entropy generation is a measure of the irreversibilities in a process. So entropy generation is not a property of the system, it depends on the path of a process. The more irreversible a process is, the larger entropy generation is. So entropy is a thermodynamic properties of the system. It is a state function. So change in entropy depends on the initial and final states only, not on the path of a process. In general, change in entropy is not equals to entropy generation. So change in entropy may be positive or negative, but entropy generation must be positive for irreversible processes or zero for reversible processes. Next. So this is how we calculate the change. The down part is the how we calculate the change in entropy. So we use mass multiplied by the Cp value and ln T2, which is the final temperature, divided by initial temperature. So entropy generation equals to change in entropy in system plus change in entropy in surrounding. So must be more than zero. So irreversible processes, entropy generation more than zero. If it is reversible processes or cycle, entropy generation equals to zero. If it is impossible processes or cycle, so entropy generation is less than zero. Next.
Okay, this is an experimental setup. In this experiment, we need three different metals, which is iron, aluminum, and copper. We also need a metal string. This metal string used to transfer the metal into the from one beaker to the another beaker. Uh, we also need two beakers because one beaker is for heating the metal, and the other beaker is to transfer the metal into the beaker, and we need to record the temperature. In this experiment also we need aluminum foil. This aluminum foil is to prevent the heat loss during the experiment, and we also need electronic balance. This is to weigh the mass of water and also the mass of the metals. We use and then we use a hot plate as our important apparatus. This is used to heat the water until about 80 degrees Celsius. So thermometer, because we need to record the change of temperature, and then a stopwatch. This is used to record the time during the experiment, because we need to record every 10 seconds of changing temperature in this experiment. So about the methodology, first we need to copper metal is weighed using the weight scale, and we need to record the readings. After that, we need to 0.1 kilogram of water is poured into the first beaker, then heat using the hot plate. Third step is place the copper metal into the beaker using the metal string. After that, while heating the metal, pour another 0.1 kilogram of water into the second beaker and record the initial temperature using the thermometer. At 80 degrees Celsius of the first beaker, and then we need to transfer the copper metal immediately into the second beaker. This is to prevent the heat loss to the surrounding. And after that, we need to cover the second beaker with aluminum foil to minimize the heat loss. The seventh step is record the temperature every 10 seconds by time interval. And the last one, repeat this experiment with other metals, which are iron and aluminum.
Okay. After do the experiment, we have get the result for the experiment, and we can look that's copper. The equilibrium temperature for from the copper transferred to the water is 31, and for aluminum is 30.5, and lastly for the iron is 29.5 degrees Celsius. So after do the calculation, you can get the heat capacity for the copper is 0.5019 kilojoule per kg point Kelvin, and for aluminum is 1.22 kilojoule per kg point Kelvin, and for iron is 0.338 kilojoule over kg point Kelvin. Uh, Next, we have the entropy change of metal. For copper, we get negative 0.0051 kilojoule per Kelvin. For metal, we get 0.0044 kilojoule per Kelvin. And iron is negative 0.0032 kilojoule over Kelvin. And for the entropy of water, we get 0.4132 kilojoule per Kelvin for copper, and aluminum 0.4139 kilojoule per kg for aluminum, and for the iron 0.4132 kilojoule per Kelvin. And lastly, we can get the total entropy generate. We can get this by sum the entropy change of metal and entropy change of water. And lastly, we can get for copper, we can get 0.4081 kilojoule per Kelvin. Aluminum is 0.4095 kilojoule per Kelvin. And lastly, for iron is 0.1 kilojoule per Kelvin. And this is a formula that we use to we use to calculate the value. Please next. Okay, for the calculation, yes, we can you can see that calculation for copper and calculation for aluminum. And lastly, at the next slide, we can see the calculation of for the iron, and we have fill in the table and to find the experimental error. For copper, we can get 30.36363636%. For aluminum, we can get 35.55555556%. And for the iron, and lastly for the iron, 24.888889%. And at the next slide, we can see the graph for the heat capacity versus metal. So that's all for the discussion. Source of error and method to minimize the error. Make sure to keep eye perpendicular to the scale of temperature to prevent parallax error, and wrap the beaker with aluminum foil to prevent the heat loss. And second, justification on the importance of stirring the water in the container to make sure the heat transfer is spread out to all water in beaker. And lastly, for the justification on the importance of transfer the hot metal quickly into the water to make sure not heat loss from the metal to surrounding.
If the distribution as per requirement, which is we need to wear our lab coat when in the lab, which is to provide a protection of skin and prevent the spread of contamination, also provide a removal barrier, which is to make barrier between our skill also the experiment when we conduct the experiment. Then we need to have a safety shoes, which is uh, designed to protect our foot from injury. Some of the most common causes include crushing, impact, and fracture. Next. So this is a precautionary step experiment, which is while we need to monitor our eyes should place perpendicular to the rating scale for parallax level. Then the metal should immediately be transferred to the water maker once heating is done. This is to minimize the heat loss to the surrounding. And close the second maker with aluminum foil to reduce or minimize the heat loss. And then the thermometer should not touch the side of the base of the container, as the container may not have the same temperature as the solution. Next. So this is a conclusion. Conclusion for the experiment will be based on the observed temperature changes in the water, correlating them with the specific heat capacities of metals. Which is the specific heat capacity of aluminium, copper, and iron are 1.22 and 0.5, 0.9, and lastly 0.38 respectively. And the value based on value of theoretical aluminum, copper, and iron, which is 0.9, 0.385, and 0.45 kilojoule per kilogram Kelvin, respectively. The result more likely demonstrate variation in the transfer capabilities of copper, aluminum, and iron based on their specific heat capacities. Moreover, the entropy generated during the process of transferring heat from the metals to the water be estimated based on the observed temperature changes and the principle of thermodynamics. Comparing these entropy changes, it appears that the order of entropy generation from from highest to lowest, which is iron, aluminium, copper. This implies that when submerged in water and undergoing the temperature changes within the specific experimental condition, ions contribute the most to the increase in entropy, followed by aluminium and then copper. Next. So this is the references that we use in all experiments. Next.